Okay, this is the second review for the final. Um, First one says find the measure of angle X. So if you're looking for this angle up here, this is a quadrilateral. Start out with 360 degrees and subtract away all the angles that you know. So you're going to subtract 125, 55, and 38, and whatever's left over has to be the missing angle. Next one, it's still a quadrilateral, still 360 to start with. We subtract away these three angles, you'll find out what y plus 9 needs to equal. So 360 minus 51, 125, and 106 will give you what's left over for the last angle to equal. On the third one, it says it's a parallelogram, and because of that, you're not going to use the 360 degrees for a quadrilateral. You're going to use the opposite angles are the same, so that means you already know y has to be 132. And then the adjacent angles, the ones that are next to each other, are supplementary. So 180 minus the angle I give you will give you what's left over for x. So you get x is 48. On number 2, we still need to do this angle is worth 78. So you're going to go y plus 9 equals 78, and then you still need to solve this one. So subtract 9 from both sides. Y is 69. Number 4, a 7-sided shape is a heptagon. Remember, you need to know everything from triangle to decagon. So 3 would be a triangle, 4 would be a quadrilateral, 5 would be a pentagon, 6 would be a hexagon, 7 we already have a heptagon, 8 would be an octagon, 9 would be a nonagon, and then 10 would be a decagon. Number 5 says classify. So if you're looking here and it says square had to have right angles, those are not right angles. Rectangle also has to have right angles, it's not a rectangle. Rhombus has to have all 4 sides the same, that has 2 and 3, so the sides are different. Parallelogram has to have opposite angles congruent, which it does, 91 and 91, 89, 89. Adjacent angles also have to be supplementary, so 89 and 91 makes 180. So that means that this would be a parallelogram. It does have 4 sides, so it is a quadrilateral, but parallelogram is a better answer. Number 6, this is a trapezoid. It's got those 2 arrows showing you that these are parallel, top and bottom. So that means that along the legs are supplementary. So over here we have 2x and 52. 2x and 52 add up to make 180, and then you solve it. So 2x equals 128, and then divide by 2, 64. For y, you're going to do the same process. So 3y and 42 makes 180. Subtract 42 from both sides. You get 3y equals 138. Then divide by 3 on both sides. You get y is 46. On number 7, you have a proportion. 2 fractions equal to each other. Just cross multiply and solve it. So when you're going this way, remember the 5 is going to affect the x and the minus 2, so it's going to be 5x minus 10. Then this way, 4 times x, 4x. To solve it, subtract, be fair. So if you subtract 4x from both sides, it's x. And then add and be fair if you add 10 to both sides. Number 8 is asking if they're similar triangles, so you need to check it by doing the fractions. Try to do small, medium, large if possible. So like right here we have 2 12s and an 18. I'm going to put the 12s first because they're smaller than the 18. And then I have 2 4s and an 11, so I'm going to put the 2 4s and then the 11. 12 divided by 4 is 3 over 1. 12 divided by 4 is 3 over 1. But 18 over 11 is not 3 over 1. So because of this one, they are not similar. And that means you cannot give me a scale factor. There isn't one. Number 9 says name the scale factor. If you're naming a scale factor on triangles that are on top of each other like this, remember it's the little triangle's left side over the big triangle's left side. So it's not 20, it's 35. On the right, same thing, little triangle's right side over the big triangle's right side. So 6 and 8 is going to be 14. If you reduce 15 and 35, they can both be divided by 5. You get 3 over 7. And then 6 and 14 can both be divided by 2. It also makes 3 over 7. That means your scale factor has to be the 3 over 7. Number 10, scale factor is going to be the same thing. So over here on the right side, if that's 6 and 2, you're not going to use 6 and 2. You're going to use 6 and 8 because you're going to add these two together for the right side of the large triangle. That reduces down and gives you your scale factor, which is 3 over 4. To solve for x, you're not going to use the scale factor. Instead, you're just going to find matching parts. So the x goes with the 4, and the 6 here goes on top of 6 and 2, which is going to be 8. And then you cross multiply and solve it. So you go 8 and x is 8x, 4 and 6 is 24. So 8x equals 24, divide by 8, you find out your x is 3. On number 11, trapezoid has a base of 3 and a base of 8. So if I have a trapezoid, those are the ones that have those parallel lines, one set of parallel lines, like that. So the base is 3 and the other base is 8. And then it says what would be the mid segment right down the middle. It'd be bigger than 3, smaller than 8. It's actually going to be right down the middle. So you're going to average the numbers, get 3 and 8, add them up and divide by 2. That's 11 divided by 2, it's 10.5 or 10 and a half. Number 12, same thing, is just tipped over. So the 25 and the 11 are going to get added together and divided by 2. So that'd be 36 divided by 2. That's 18. Number 13, it's another trapezoid. This time we're working with the angles. So on the leg, these are supposed to be supplementary. So 180 minus 49 is 131. And then for D, since it's isosceles for this trapezoid, if that's 49, then D is also 49. Number 14, measure of angle 1. So on the exterior, these always add up to 360. So that means subtract all the angles you know and you'll find what's left over for that last angle. So subtract 80, subtract 70, subtract 50, and subtract 130. Whatever's left over has to be the missing angle. And you've got 30 degrees left over for the missing angle. Number 15, diagonals of a rhombus are perpendicular. Diagonals for a rectangle are congruent, which is the little equal with the squiggly sign. So right here, diagonals of a square are perpendicular and they are congruent. And this last one, diagonals of any parallelogram will always bisect each other. Number 16, what can you say about the opposite angles of a parallelogram? So if I'm looking at a parallelogram, opposite angles should be congruent. On this problem, it says find the perimeter and the area. For the perimeter, remember that all you have to do is get the two longest sides, so the 4 and the 5, and whatever that is, double it. So that means that your perimeter would be 9 times 2, so it'd be 18 meters. When it comes to the area, you find the area of the little rectangle. So on the left side, you have a 3 by 4 rectangle, which is 12. And on the right side, it's not 5. You're going to subtract 3 away from 5. It's going to be 2 by 2, which is going to make this side 4. That means your area would be 12 and 4 together. So it's 16 meters squared. Number 18, on a triangle, remember it's like half a sandwich. So use like the rectangle formula, 7 times 3, and don't forget divide by 2 at the end. So 21 divided by 2 is 10.5. Number 19, the parallelogram, you treat it like a rectangle. So you just multiply the base, 5, times the height, 11. And then number 20, for the rhombus, it's the diagonal, 6, times the diagonal, 8, and then divided by 2 because you're missing all 4 of your corners, which is half the area. So this would be 48 divided by 2, it'd be 24 units squared. Trapezoid is base plus base divided by 2 multiplied by the height. So 9 and 5 would be 14 divided by 2 would be 7. 7 times 7 is 49. On 22, asking for a circumference and the area. So for the area, it's pi times the radius squared, and the area is 254.34. For the circumference, it's going to be 2 times 3.14 times your radius, and it's 56.52. Next problem says a regular polygon. It's both equiangular and equilateral. And then 24, the angles right next to each other on any parallelogram. If you think about your parallelogram, the angles that are next to each other, they're not the same, but they are supplementary, which means they're going to add up to 180. And then for this problem, a rectangle you just multiply, so it'd be the square root of 3 times the square root of 12, which is the square root of 36. That reduces down, and it's just 6. 26, you're still going to multiply these together because it's still a rectangle, so it would be 3 square root of 6 times 5 square root of 2. And then the 6 can get factored out, and it's easier to see that you have a pair of 2's. So you have a 3 outside, you have a 5 outside. Because of this pair, you have a 2 outside, and 3 is the only thing stuck inside. And then you're going to go 3 times 5 is 15, 15 times 2 is 30, so it's going to be 30, and then the square root of 3 is inside, and that would be your final answer. Number 27, to simplify a radical, you factor it out. So 56 is 2 times 28, and 28 is 2 times 14, and 14 is 2 times 7. So there's a pair of 2's, goes on the outside, and this 2 and this 7 that don't have pairs stay inside and multiply back together. 48, same thing. So for 48, you can go 3 times 16, and then you can do 4 times 4. And if you happen to see that you have pairs, you don't have to keep factoring that out. 4 goes outside because it was a pair, and 3 stays inside because it was by itself. For the circle problems, remember that if it looks the same, it's the same. So like on this problem, 5x minus 2 equals 3x plus 16. And then you're going to subtract 3x to both sides, and that gives you 2x. You're going to add 2 to both sides. It's going to be 18. And you find your x is 9. Number 30, this chord is the same as this chord. So 3x plus 2 equals 20. Subtract 2 from both sides. 3x equals 18. Divide by 3 on both sides. X equals 6. Number 31, this arc is congruent to this arc. So 10x minus 5 equals 2x plus 57. If you subtract 2x from the 10x, you're going to have 8x on the left. And if you add 5 to 57, you get 62 on the right. And then you divide both sides by 8, and you find out your x is 7.75. Number 32, the 100-degree arc means that at the center, you would have a 100-degree angle. Since it's pulled back, the angle got smaller, it got narrower. So divide this by 2, and you find out it's 50 degrees for that x. 33, if a triangle is inscribed inside of a circle, then that means the diameter ends up being the hypotenuse of a right triangle, so x has to be 90. Once you know that this is 90 degrees here, and you know that angle is 28, you can do 90 minus 28 to find the last angle. So 62 degrees for y. 34, on a quadrilateral that's inscribed in a circle, the opposite angles are supplementary. So if that's 109, then y is going to be 180 minus 109. And then x and 43 are going to be supplementary this way. So it's going to be 180 minus 43 for x. And then you find out your x is 137. Number 35, you multiply down the lines when they're crossing like this on the chords. So 3 times y is 3y, 6 times 10 is 60, and then you solve this. Y is 20. On 36, this is the average of these two arcs, so you'd get 50 and 66, I think that says. and divide it by 2. So that would be 116 divided by 2. You find out your y is 58. 37. If you saw that this was adding them out, dividing by 2 to get the middle, you're going to follow that same pattern. The y in the 94 divided by 2 is supposed to make 71. To get rid of this fraction, you multiply both sides by 2, and then you get y plus 94 is 71 times 2, which is 142. Then subtract 94 from both sides. Y is 48. It says name the term that best describes the line or the segment or point. So FE right here is a segment from F to E, from the center out. That's a radius. And then DE is also a segment from D to E going across the circle but not at the center. If it stops, like this doesn't have arrows on it, that's a chord. And then for F, F's right at the center. Let's just call the center. DE, now that it has arrows on it, says it's a line going through it. That's a secant. And then B is that point where the tangent line is touching the circle. So this one is your point of tangency. And then AC is a line that's only hitting that circle once. So this is the tangent or the tangent line. 39, if you see something that has a radius touching a tangent line, these are going to be problems where this is a right angle at that point of tangency, and then you use Pythagorean theorem on this triangle. So it's going to be r squared plus 24 squared equals 28 squared. R squared plus 576 equals 676. Then you subtract 576 and you get r squared equals 100, and you divide by, you square root the r squared and you find out your r is 10. 40, kind of the same process. This is still a right angle right here at the point of tangency. So these two legs, the r and the 12, are still going to go on together, r squared and 12 squared. And then your hypotenuse is actually going to be r plus 8. So 12 squared is 144, and the r plus 8 multiplied by another r plus 8 is going to give you r squared plus 16r plus 64. Then you cancel the r squareds, you get 144 equals 16r plus 64, so you subtract 64, you get 80. Then you divide both sides by 16, and you find out that it's 5. Number 41, the jack-in-the-box problem. Remember, on jack-in-the-box problems, these are equal to each other. So 7x minus 2 equals 4x plus 10. Subtract 4x from both sides, add 2 to both sides, and then divide both sides by 3. And you found x. And then number 42, you want to find all of the little pieces. So if it's 32 degrees up here, that means that down here is also 32 degrees because vertical angles. And then if you know that this is 91 and this is 32, you can go 180 minus these two angles, and whatever's left over has to be between D and E. So right here is 57. And then this last piece over here on the right has to be 180 minus 32. So this part is 148. And now we can find the pieces that we want over here. So DC, 32, we already found it. BEC, B, E, and then C would be everything except for the 148. So 360 minus 148 makes this 212. And then arc BC from here to here, we already have that, 148. And then ED, we already have that, that's 57.